Morning, everyone, and welcome to the beauty of stupid ideas. Just wanted to start off this talk with a warning. The following slide deck is going to contain examples of bad code and poorly thought out ideas. Do not try this on a production system. I'm a trained professional. Go with professional on that one. I want to open this talk with a bit of a story. This is me in 2013. I was getting married. I want to be clear that that wasn't the stupid idea. My wife saw me putting together this slide deck. You saw this photo from our wedding in there, and she's like, why is there a photo of us at our wedding in the slides? I told her which talk it was for. She's like, why is it a talk about stupid ideas? So I want to be very clear up front that getting married wasn't the stupid idea. That's why. That's why it's in the slides, hon. I'm sure she's going to watch this video at some point. But we did after our wedding. We did what you tend to do on after a wedding. We went on a honeymoon. We went away for a week. We went to a rainforest retreat in northern New South Wales. Isolated. There was no real phone reception, no internet, really, anything like that. So I did what any good IT person would do. I took my laptop. You might be starting to kind of formulate where this kind of bad idea could be coming from. Well, the reason that I did was, like I said, we were going to be away, isolated. I wasn't going to have any outside distractions, and there was this really popular new JavaScript framework that was, or at least it wasn't particularly new, but it was making a lot of traction, particularly in the Microsoft space where I tend to play. You might have heard of it. It's called AngularJS. It's still kind of popular from what I can gather, but it was really starting to make waves, and there was one particular feature that I found really interesting about it, and it was that it had dependency injection built into it. Is something that, as a .NET developer, and I'd spent most of my career writing .NET applications, I had it kind of beaten into me that DI was a really good thing because it made things like testability a whole lot easier. And I'd been doing front-end development for a while, and I never kind of thought of it in that space, that it was something that could be needed. But it was a big selling point of AngularJS, and it's why that I saw it as a very popular and interesting framework to get involved with. So there would be code demos all around that you would find like this, and it had really interesting things like you'd inject things like $scope and $locale here, which were these things that were coming out of the loosely described type system inside of AngularJS, and you were able to resolve these, and the way it created the controller, it just magically knew what $scope represented, what $locale represented, based off of how they worked. And what I found really interesting was thinking about how did that actually work? Because you could write code like this and it would run in the browser, and JavaScript doesn't have a type system, and that was what I understood about dependency injection. That was how you did dependency injection, is you needed to know about types so you could know what to inject. And it also, one thing that this kind of example didn't really take care of was what happens from a minification perspective, where these two things are called $scope and $locale. They'd become A and B, or something equally less obvious about what they originally were. And so then we would look at things like the $inject property, or we would pass in the array where we'd have string representations of all the arguments that would get inserted. Now, so it had been bugging me for a few months at this point, like how this all kind of came together. How would it work under the hood? And I really wanted to know, but I simply didn't have time. I had a wedding that I was, at least I was pretending that I was helping plan, but let's be real, I probably wasn't really doing anything constructive in that space. We'd bought a house, so there was all this stuff going on. I just didn't have time to sit there and follow an esoteric idea of how to write this in JavaScript. How does it work inside of AngularJS? But one lazy afternoon on our honeymoon, my wife was having a nap on the couch, and I was like, well, time to write some code. So I cracked out my laptop and started playing around, thinking about how could this work. And I came across I realized that the function object inside of JavaScript has a toString property, a toString method. What does that method do? So execute that method. Oh, hey, I've got the original string, or the function as a string, as was parsed by the JavaScript runtime. Well, that's kind of interesting, because if I've got a string, I can then introduce a regex that can walk over that string and pull it out. And this is the basic core of how it takes that function in Angular and turns it into the arguments that you would be passing in if you don't use any of the more explicit dependency injection options within inside of Angular. This is actually slightly simpler than the Angular one because it doesn't take into account of putting comments inside of between the open and closed parentheses and stuff like that. But at the end of the day, this was how it would work. So I wrote a thing. My wife was still asleep on the couch, so I decided to write a thing and publish it to GitHub. Well, at least I published it to GitHub when we got back from our honeymoon. So I wrote an IOC container in JavaScript. Why? As I said, I'd been doing front-end development for a couple of years at this point, and coming from a .NET background, I knew all about IOC and why it was valuable, but I'd never found a need for an IOC container in JavaScript. I'd never needed one. But I'd just written one, and at that time, if I went to any of my colleagues and was like, hey, you know what we need? We need an IOC container in JavaScript. They'd just look at me and go, really? No, we don't. There's no need for an IOC container in JavaScript, but I've done it. Yay! So it was kind of a stupid idea to sit down and do that, and for no value really whatsoever. At the end of the day, no one needed this. No one needed this problem solved as a general purpose IOC container in JavaScript. But it's been really valuable for me in kind of learning some of the more advanced features of JavaScript. And in my day-to-day job, it's been very valuable for helping to illustrate things in JavaScript, like how you do partial application on a function. How do you pre-bind arguments to pass that function around, and why does that work, and how that can be valuable. The internals of this AutoFact.js that I wrote, it does a whole bunch of that stuff. It does pre-binding of arguments, and it starts then exploring the idea of function carrying, which is, if you've done functional programming, that's obviously a very valuable thing to understand. And as I've started to explore more and more about functional programming, I've understood a lot of the concepts that they're talking about there because I did it in a language that I was familiar with for a problem I didn't need to solve that I can now translate into other languages, other places that I actually have problems that I want to solve. Also, I learned that you probably shouldn't write code on your honeymoon. That's also why this was probably not the best idea. It was a bit of a stupid idea. But at the end of the day, it all comes down to why. And that's the crux of this talk. I want to talk about why we do these sorts of things, why we follow stupid ideas, and why we should encourage people to embrace stupid ideas. So, back to the introductions. My name's Aaron Powell. I'm a consultant. So this is me in my day job, consulting and all that kind of cool stuff. I'm from Australia, if the accent hadn't given that away for you just yet. In Australia, the consultancy I work for is called Redify, and we've worked with some of Australia's largest banks. I've worked for some small startups, companies that have hundreds of developers, companies that have tens of developers, companies that have one developer. I've worked with them all across that kind of space. So I've seen a lot of different working environments and a lot of different ways that we can encourage people, motivate people to do a better job. And part of being a consultant, part of being in IT is constantly wanting to learn. And that's what doing something like an IOC container in JavaScript was all about. It was a chance to learn. I'm also a huge Simpsons fan, and be prepared for a lot of Simpsons images throughout the rest of this talk. So back to bad ideas. This time, I want to talk about Git and something that I was theorizing and doing in the ways of abusing Git as a source control system. So back in the height of the source control wars between Git and Mercurial, those dark days. We were seeing, as soon as companies like Microsoft started embracing Git and it was becoming a first-class citizen inside of things like TFS and then later on VSTS, and now they're pushing things through to GitHub and stuff like that, we were starting to see Git become more popular, particularly in big enterprise. Companies that were very traditionally TFVC in TFS or SVN shops, and were very regimented in the way they work. But we were starting to see a lot more opportunities for Git coming up with inside of our clients. And that meant for me as a consultant, I was often going in and having to teach people how to use Git. And these were people that had potentially never used a distributed source control system, or in some rare cases had never even heard of source control before. Those were the really fun ones to work with. But because I was doing a lot of training, I really wanted to understand how Git was working internally. Because while that might not be the kind of thing I have to explain to someone up front, if I could talk about the really high-level concepts as well as the fundamentals, and I knew the fundamentals really well, so what are the basic building blocks of Git and how that all works? If I knew that kind of stuff, I could talk to them about why you would use the Git inside of Visual Studio tooling, or why I'd be using SourceTree, or any of the other Git GUI tools, or then if they wanted to go advanced in command line, I could explain all of that stuff and relate it back to things that they might be a lot more comfortable with, a lot more familiar with, rather than just focusing on all these terminology that we're throwing out there. Here's doing a pull request, and this is how you click buttons, and magic pull requests are all happening for you, and that kind of stuff. It also, I wanted to be able to go in and, if there was a problem with the Git repository that someone had on their machines, the solution to that wasn't, just delete it and clone it again. Because that was too often the time the case, particularly someone that had never worked with anything other than TFS. And if they got to a bad state, it's just easier to delete and fix it up. So I wanted to know the underlying workings of it, so that I could help them through that pain and potentially not lose any work that they might have done that has not yet been pushed and things like that. Oops, wrong button. So I had this idea involving chess. I used to play chess when I was younger. I was never particularly good at it, but it always resonated quite nicely with the logical part of my brain. So I was thinking about how chess and Git could work together. Now, bear with me, because remember, this is a talk about stupid ideas. So I'm going to. So I see, if every move could be represented as a commit in Git, we could then branch off every single move. You could then use the underlying data structures that work with inside of Git to be shared across branches, because there's a finite number of moves that can ever happen within chess, or there's a finite number of layouts of pieces on a chessboard, and the number of layouts, as you remove pieces off the board, then you've got different ways that you can achieve that same layout. So you could use the same underlying data structure. The blob is what it's called within inside of Git, multiple times. So you could then, and this was what I was theorizing, was you could then represent every potential outcome and then just walk the Git branches and make it like a little bot that would sit there and essentially play chess against itself by traversing Git branches to work out, if it played this move, what were the potential outcomes that it could get to at the end of the game. Where is it going to be in 10, 15, 20 moves time? Because that's how chess AIs tend to work, is they try and predict where they're going to be. Well, if you had every potential outcome, you could then work out every potential way the game could go based off of the move that you play. I mean, that was the theory, at least. Turns out that this is a little bit more of a complex problem than I was initially hoping it would be, and initially anticipating it. Turns out there's actually a lot of moves that can be done in chess and a lot of potential outcomes of a game. Somewhere between 10 to the power of 40 to 10 to the power of 50 in one Stack Exchange thread. That's what they theorize the potential number of placements and outcomes that are based off of those placements. There's another school of thought that is that the number of moves inside of chess is greater than the number of atoms in the observable universe. So you're probably going to run out of hard drive space if you try and model this in a Git repository. Like I said, it was a good idea in theory. And I talked to one of my friends that works at GitHub, and he's like, yeah, you could probably do that. I don't think it's a good idea, though. So it was a stupid idea. So I thought I'd try something a little bit simpler. I'll go with tic-tac-toe. There's only two colors. There's only 9 squares. There's a whole lot less number of moves that you could actually potentially do. All right, so how does it work? And doing this, I wanted like I said, I wanted to learn the underlying structures of Git. So we started off with the Git hash object function, or Git hash object thing. I can't remember if they're called functions or not. So hash object, it takes an input stream. It can take something from standard in, or in this case, I'm actually reading it from a file on disk. So that file is representing my game state, my board, as it were. The contents of this file is a 9x9 set of whitespace characters, representing the start of the game, an empty board. The -w flag says that you're going to write this to the Git objects when you run hash object. So you can hash object over an input stream and it'll give you the SHA that you would get. But in this case, I want to actually write that. That creates a brand new blob inside of a Git repository that's unattached to anything. It's just a bit of data that's sitting inside of Git. It lives inside of the .git/objects folder. So if you've ever poked inside of there, you'll see a whole bunch of folders, generally 2 characters in length. It's the first 2 digits or first 2 characters of the SHA that you've got. So in this case, I would have a folder called 27, and then inside of that, a file with the rest of that file moniker, so 88 onwards. So I've created a blob that lives within inside of Git that is not used anywhere. The next thing we want to do is we want to use that blob. So I'm going to use the update index command. What this does is it takes the SHA that we generated for that blob previously, and it adds that to your Git stage. So if you do git add, it's essentially putting everything in that stage. But instead of using the files that are on disk, it's using a blob that we've previously created. Now, what I'm doing with this blob is I want to actually create a file within inside of the Git stage. So I've created a file called tictactoe.text. Not exe. Don't want to actually run it. So you'll notice that this file name is different to the import file stream that we've got. So what I'm doing is I'm creating something within inside of Git that is just it's just a file that it knows about that I could restore from there, but it's not actually representing anything that's on disk. I don't have that file anywhere on my hard drive. And this is where I started to learn how Git works internally. It's actually very similar to a Unix file system. I could have cut in a Jurassic Park image of it's a Unix system, but I didn't. So because this is a Unix file system, or has a lot of similarities to a Unix file system, I have to give the file that I'm creating in that index some file system attributes, so it's readable and writable and all that kind of stuff. So that's the cache info that I've got there. So this, like I said, it adds it to the stage. And then the next thing I need to do is I need to start actually creating that file system. And I do that with a tree. Git write tree takes what's currently in your stage and creates a tree within inside of your Git index. Your Git objects. Again, this ends up in your .git/objects folder. We'll have a folder called 90 and then a file inside of that, which is the rest of the information. And a tree is essentially a folder structure. So because this is sitting at the root of this particular Git repository, so that will, this tree represents like / in the file system, but you would then have multiple trees to represent folders that are files within inside of folders and stuff like that. So you would have a tree that has blobs that have trees and so on and so forth, and that's how you would build up a complex file system or a complex folder structure within inside of Git. So we've now got our tree, which points to a blob, which is now something we want to commit. So we want to create a git commit. So I use the commit tree command. I take that SHA from the tree that I created on the previous slide. I give it a message, so I get a lovely commit message, and then this gives me a SHA of that commit that's been created. And there we go. Congratulations. You have just committed one file to a Git repository. I can then use that SHA and use commit tree again, plus the previous commands, and pass that SHA to a -p flag, and then I create, that's giving it a parent commit. So I now have a commit that has a parent, so I could do diffing across them. I could then create another commit that has that next commit's parent, and so on and so forth, and that's how you start building out a branch. If I create another one that has that uses the parent of an existing commit, well, now I've branched from that point in the Git repository, going so on and so forth. Was this particularly useful? Probably not. artisan hand-rolled Git repositories using just hash object, commit tree, write tree, and update index are not really the easiest way to go about working with Git. Definitely not. Things like add, commit, those sorts of things, they're a whole lot easier. But now we know the building blocks of how Git works. We understand the underpinnings of it. Then you can, if you know what's happening at the base level, it gets easier to start relating those concepts. Why do we have files and folders? And if I've created a file, I've created a folder, and then why can't I add just that empty folder into a Git index? Well, because it doesn't have any files inside of there, so Git doesn't understand those kinds of things. And that's a very common one for someone that's come from a TFS background. Well, why can't I just create that folder? TFVC, more accurately, allows me to have an empty folder with inside of my source control. Why can't I do that in Git? Well, because it actually expects files inside of there, and folders don't really exist. They're just trees of object graphs. And that's as far as I got. I actually only got to about 3 moves in and went, well, this is just super tedious. So I decided to stop playing or stop writing a Git repository on top of just hash object and such. So you're probably never really necessarily going to use those commands directly, but knowing that they're there can be valuable. So back to the underlying theme that I'm hopefully conveying throughout this talk is, how do we motivate people inside of the organizations that we work with? How do we make our staff happy? At the end of the day, we want to make sure that people are happy where they work, so that they're less likely to leave, that they enjoy their job, that they're giving it their all, and all those fluffy things that we tend to say about people and working inside of organizations. But at the end of the day, we want to make sure that our staff, our colleagues, are happy. Okay. Traditional management will say that you throw money at them. That's how we make someone happy. The more money you pay someone, the happier they're going to be at work, right? That's how management works, isn't it? I mean, we are moving away from this kind of mentality, but I still know a lot of people that they're purely motivated by money. Now, there's nothing wrong with being motivated by money to do a better job, but the problem is that if someone is purely motivated by money at work, they're always going to be chasing money. Someone's always going to have more money for them, so they're going to follow that rather than stay with your company and try and do the best they can for you. So this is commonly referred to as the carrot and the stick type of management. But what research is telling us is that people, they just generally want to do a good job. They genuinely want to have fun at the place that they work. That they genuinely will just want to do a better job than they did yesterday. And this is particularly in a creative industry like IT. People are going to want to be better and continually improving themselves and things like that. I was actually talking to a dev manager at one of my clients about this talk and what I was talking about here, and the carrot and the stick problem, because we're working with him and his team leads. And he actually gave me a really good anecdote that I'm stealing for this talk, and that is that if you're approaching management with a carrot and stick mentality, any sufficiently large carrot can also be used as a stick. Keep that in mind. So, if we're trying to make a learning environment, and that's the way that we motivate people, how do we encourage learning? It comes down to trust. Not necessarily the kind of trust that Hank Scorpio is demonstrating here, but actual trust. We want to give people room to experiment inside of in a safe environment. In a company that they're happy, and that management is not going to make them feel bad if they don't succeed in everything that they try. So don't discredit failure. Failure is a great learning tool in life in general, but particularly in IT. You do something, that's why we refactor code. Code we wrote yesterday is rubbish. The code we write tomorrow is amazing. And the code we're writing today it's going to solve today's problem. So we really want to give people room to learn. The classic adage that people, a classic example that people have when you're talking about room to learn is Google's 20% time. Now, the jury's kind of out at the moment of whether Google still does the 20% time. Some people say it's 120%, so you have to do the 20% on top of your day job. But the idea of the 20% time is giving their employees time out of their day-to-day tasks to explore, to experiment, to try things and follow ideas that they've always wanted to follow. We've seen heaps of really interesting projects come out of Google 20% time. Probably the biggest example of that has been Gmail. Gmail started as a 20% project inside of Google that has obviously become a bit bigger than 20% time. I think it's about 25% time now is used on Gmail. But it's been one of their most successful platforms. Atlassian is a great example of an IT company in Australia that's done very, very well for themselves, and they have this program that they run called Ship It. It's a 24-hour time window that you have to deliver value to the company. And this can be done in many different ways. They've had, it's been 24-hour bug bashes against things like Jira. They've had tools like the Jira Service Desk actually started as a Ship It project and then evolved into obviously something that is now part of the Jira platform. There was a 20% project, a Ship It project where they went around and replaced all the light bulbs on the floor with energy efficient light bulbs. That's giving benefit to the company long term because it's saving money, better for the environment, those kinds of things. It could also be seen as a social experiment. Maybe don't go and just change all the light bulbs to green to see if that has a positive outcome on your colleagues and your employees. But those kinds of things are other ways. If someone said, "Hey, I'm going to go replace every light bulb on the floor," it sounds like a great idea, and everyone's going to go, "That sounds like a stupid idea." Or you might have someone in management that goes, "Go for it. Let's see what happens." And that's one way to approach motivating people. A company I work for, Redify, we have similar to the 20% time as PD time, where we can take paid leave essentially to work on something, to do something that we want to upskill on, we want to learn, we want to get better at. We want to come to a conference like this and present. We've had a number of open source projects that people have built using that 20% time because there was something that they wanted to learn, to explore, and out of that has come something that they've felt is valuable enough for other people to then run with and publish up. So I want to talk about something that started for me from a PD time that I was, and something that seemed relatively simple, an idea when I first started, but at the same time, it was still a pretty stupid idea. So, what if I said, let's write our own number system in C#? Do you point out that computers are actually kind of good with numbers and that we probably don't need to write our own number system? Yeah, like that's what computers do. Just shake your head and walk away. Really, like you're going to write int in C#? I'm pretty sure they've done that. Just saying. Do you remind me that it is actually a really stupid idea? And these are common things when I tell people, hey, let's write a number system. So we know how numbers work, right? Right? Like we know that if we add two numbers together, we get the sum of them at the end of the day. And we 2 plus 2 is something around about 5. For a sufficiently large value of 2, we get 5. Math nerd joke there. Not enough math nerds here? I'm a little bit of a math nerd, but not enough of one to really, truly have appreciated the code that I'm going to walk through next. So I thought, well, creating your own number system can't be that hard, can it? Computers are really good at it, but sure, I can totally do this myself. It actually started, I was at a conference in Australia, JS Conf AU, a couple of years ago, and there was a presenter that was doing a talk about surreal numbers. It was in amongst a kind of a talk like this about crazy things and that he was doing. So he was talking about surreal numbers. So if there are any really big math nerds and or mathematicians in the room, I'm going to apologize for probably the next 10 minutes of this talk where I just completely do things wrong about mathematics, because that's probably what I'm about to do. But surreal numbers is based on the idea of working with sets of data. So we start off with like an empty set, which represents 0. So I'm just using empty arrays, and it has a left and a right component to it. So this is it's a set that has 2 empty sets that represent 0. Represents 1. We have something on the left-hand side, which is an empty set. So we have 1 empty set on the left-hand side that represents 1. We have an empty set inside of a set, which represents 2. And again, this is a positive value, so it's on the left-hand side. For negative values, it's on the right-hand side, and similarly, and so on and so forth. So we basically represent, we can represent numbers as these collections of sets. Oops. All right, so I'm actually going to jump over to the code, to some code, because at the end of the day, this is actually theoretically a technical talk. So I want to show a little bit of code at the very least. So I wrote a thing. I wrote an implementation of Surreal numbers in .NET. And well, by doing that, I needed to, I had these 2 things that I said were numbers, so I needed to be able to treat them like numbers. If I created 2 Surreal numbers based off of some input that I received, they should be equal to if they were just int values that I was adding together. So if I take 0 and 1, I add them together, I should get 1. Or if I take 1 and -1 and I add them together, I get 0. Yeah, I get 0. Like I said, not enough of a math to be able to just do this completely off the top of my head, but enough that I'm pretty sure that this code all works. I mean, the tests all pass. So, yeah, ship that to production, right? And because this is not necessarily, like the Surreal number is not necessarily useful unless I can convert it back to a real number. That's how I would then do equality testing. So I do an example here and add Surreal 1 to Surreal 2, and that should be the same as adding A and B. Right? So if we have a look at how that is implemented, I do some unboxing of the 2 Surreal numbers that have been passed in, create new instances of them. The reason that I'm doing that is because this actually uses a whole bunch of mutable data structures instead of immutable data. That is just through sheer laziness. If you want to do this properly, you'd have these as immutable things, and then they would be a lot more akin to the way int and float and double and such work. But this was not to ship to production, so we can deal with the fact that there's some hacks in there essentially. All right, so we've got the 2 values. I'm going to treat. Sorry, we've got our 2 values, and I want to look at, is the right-hand side of the operator a positive or a negative value? If it's a positive value, we're just going to loop around and increment the left-hand side of our operator while decrementing the right-hand side. So essentially, we're taking 1 from the right and moving it to the left, and we keep doing that until we get to 0. If it's a negative number, we do the opposite, but so essentially we decrease the left-hand side while increasing the right-hand side, and again walking back up to 0. So I know how addition and subtraction operators work. I learnt that when I was like 5, 6 years old and that kind of stuff. That kind of mathematics is really simple, right? You know how that works. But it wasn't until I sat down and wrote this code that I really had that light bulb moment of like, oh wow, that's right. That's how addition works. It is really just take something from here and move it to here. And subtraction is the opposite. I have a young son at home, and I know that at some point I'm going to have to help him with his maths homework. I now feel a lot more confident in my ability to explain that to him in a really simplistic manner that he's going to be able to grasp when he's 3, 4, 5, 6. And hopefully after that he'll be smarter than me at maths. But that's how it works. And then if we expand that out into a multiplication or division operator, essentially that's addition, but inside of a loop. If we multiply 2 numbers together, it's actually it's addition n number of times. So we can do that. That's actually really simple. It just builds on top of the addition operator that we've got. Again, I've got some little shortcuts in here to check if something is or isn't 0. If it's 0, then I know I can bail early because I know that 0 multiplied by anything is going to return me 0. So I can just short circuit that. But I could essentially prove that through my own code. If I remove that and then did the multiplication, at the end of the day, we're going to get down to 0 anyway on one of the by doing this recursive operation. Division is a little bit more tricky because you've got remainders. So it's fine if you're doing like whole number division, so like 9 divided by 3. But if you do 9 divided by 4, well then in surreal numbers that actually gets really tricky. Like how do you deal with the remainder? And this is designed to replace int, not designed to replace doubles or floats or anything like that. Okay, so once we understand how we can do things like elementary arithmetic, we probably also want to be able to say, is one number greater than another number, or less than another number, or less than or equal to, etc., etc. How do we implement all of those? Well, if something is less than, well, it's definitely not greater than or equal to that, right? So that's how you do less than. It's just not greater than or equal to. Is something greater than or equal to something? Well, it's less than or equal to it, right? And the greater than and less than operators cancel each other out. The equal side of that statement will then match. Right? So that's how, if it's equal, then it's definitely greater than or equal to that as well. I'm pretty sure that this code all works. And then greater than is essentially the opposite. So it's not less than or equal to. So really, at the end of the day, you only actually have to implement one of those 4 test types. So I've just implemented less than or equal to. We clone our values. I check if they're negative or 0, and the other one is also the close solution explorer. If the other one is positive or 0, then this is just short circuit code so that I can bail out early rather than having to actually do the complex logic down below. But it's a lot of just testing something as against 0, and then is it positive or negative, and then process of elimination to eventually determine is something who gets to 0 faster. That's the final bit that we get to on like line 10 and such. This is just a race to 0. I realize that this is probably inefficient because I decreased both of them at the same time, and one will hit 0 before the other. But if I just race this one to 0, if it gets to 0 before that one gets to 0, then we can bail out, and then that's how we determine if both of them are positive numbers, is it less than or equal to. And then obviously I got a whole lovely test suite that covers all of those things off. All right, back to our slides. So there we go. That's how you implement your own number system. Again, I pushed this up to GitHub because it was really useful code that I'm sure other people can learn from. But yeah, I really did find out that computers are pretty good with working with numbers. People had already told me that, but I now have proof myself. I've worked out why computers are really good with numbers because someone a lot smarter than me has worked out how to write a number system that is a lot more efficient than mine and built it a lot more low level than on top of the .NET runtime. But I said this is where I started to understand a lot more about the things that I just take for granted in the way that number systems work. That really negation, less than, greater than, and all those sorts of tests boil down to different combinations of the same check and the value 0 and why 0 is such a special magical number to deal with and why 0 is really very important with inside of mathematics. And that elementary arithmetic, addition, subtraction, multiplication, division, and then I didn't kind of explore further than those 4 operators, but if you think of things like power of operators, they're just recursions on top of recursions on top of recursions on top of addition at the end of the day. So it all comes down to add or remove 1, really. I was giving this talk at Redify to my colleagues, and one of them said, well, how do you prove that 1 plus 1 equals 2? And I just kind of moved on from that point. His partner is actually a maths teacher at school, and it turns out to prove that 1 plus 1 equals 2, you're looking at hundreds of pages of mathematical theorem. So it's provable, definitely. It's actually very complex to prove that addition and subtraction work, and a lot more difficult than I ever intended to go into. But I'm not constrained by the primitive notions of max value inside of your number systems. I don't int.max value. That's not a problem. I am constrained by CPU and memory and time. I tried to do int.max value plus int.max value because I can go beyond that, even though the inputs are ints. 6 hours later, I decided that I wanted my computer back, so I terminated the program. I actually have no idea how far it got when doing that addition, mostly because I have no way of debugging what the real number is inside of it, other than trying to walk the internal data structure that I've got, which is actually an INumerable of empty objects. So it's actually then an INumerable of INumerable of INumerable. So trying to walk that is actually very slow as well. So to get the real value is kind of, a problem. So I'm only constrained by CPU, memory, and time. Maybe it's something for the cloud. So why do we do something like this? Why do we go out and make a crazy number system? Is it to make people happy? Is it so that I can go, yeah, like, look at me, I'm making people happy, and like be like really sarcastically happy about doing that? Not really. It comes back to this idea of intrinsic motivation. Intrinsic motivation is that people have a desire to solve a problem, regardless of the reward that you're trying to give someone. This going all the way back to talking about the carrot and the stick approach to management. You don't have to dangle money in front of someone to make them do a better job. People naturally want to do a better job. We want to share our experiences. That's why we get up at conferences like this, talk about something crazy like I'm doing here, or any of the other talks that are happening this week. We want to share what we've learned because it makes us happy. It's exciting, regardless of whether or not it's going to solve a problem that you've got tomorrow. It might spark an idea. Like seeing someone talk about how to write a number system sparked the idea of, well, I want to know how that works myself. To have the satisfaction of saying, well, why not? I'm sure I can make a better wheel. That's kind of where it comes down. What it comes down to. We do all these things because it makes us happy. We're motivated to do that, and then if someone does something and it is amazing, and we give them that feedback afterwards, we tell them that that was exciting. I learned something. It sparked an idea in me. It's given me some passion to follow a stupid idea. That is often reward enough that we don't need to pay someone to have done a better job. That knowing that they've made something that someone else is finding exciting, that can be motivation and satisfaction enough. So I want to talk about my fourth bad idea. It's not as silly an idea as some of the other things that I've talked about here, but it's still, this was one of the first things that I did that I think was really crazy. So this will be the final story for this talk of our journey of bad ideas. So, scene is, it's circa 2008. I'd been in the IT industry for about 3 or 4 years at that point, so I was still fairly junior in the company I was working for at the time. And we just started using an open source content management system called Umbraco. And as I said, this was circa 2008 .NET ecosystem, so open source was not particularly a big thing. There was also something else happened really exciting in the .NET environment in 2008, and that was the release of Visual Studio 2008, .NET 3.5, and with that came Link. To me, Link is kind of the feature inside of .NET. It's the thing that, if I'm talking to someone about .NET compared to other programming languages, this is the thing that I say, this is the reason why I write .NET and why I love .NET over the top of many other things. I've written implementations of Link in things like JavaScript because I've wanted it there because I think it's such a cool aspect of .NET. So I was starting to look at Link, and I'd been reading all the stuff as it was coming up to its release, and what they were talking about was Link to SQL and how awesome it was for working with SQL, and Link to objects and how awesome it was for that. But I wanted to know, what could you do with Link beyond SQL? on the kind of on the edges of the .NET community, there were some really smart people that were talking about using a link, but not with SQL, but with using it with other things. There was a blogger that I was following that now works for Microsoft that was looking at it for working with PowerShell, sorry, not PowerShell, Active Directory. So he wrote a way of working with link over the top of Active Directory and all kinds of crazy stuff like that. So I had this brilliant idea. I would write my own link provider. Like I said, I was still a fairly junior developer. But I had this idea. I could totally write a link provider. And I thought, well, what would it be useful for? Well, I'm working with Umbraco at the moment. And Umbraco it's a mid-2000 era content management system. So it's using XSLT. If you weren't using XSLT in a content management system in early to mid-2000s, I don't know what you were using. You were probably using WordPress. But everything else was using XSLT. And as a .NET developer, that was not the kind of thing I wanted to be writing. I did not want to write XSL daily. It was not fun. They had a .NET API that I could work with, but it was okay. It definitely wasn't written to the caliber of .NET API that I believed should have been there and that I believed that I could write. So I decided I would write a link provider for Umbraco. Okay? That seems like a good idea, right? A link provider to a content management system. How hard could that be? It seems like a natural thing. So it's an open source project, so I can get started with this. I can easily pick up the code and start working with it. But I kind of wanted to validate my idea with the core team that was behind the project to make sure that they weren't thinking of something in this space or anything like that. So I had to work out, how do you get in contact with a bunch of developers that are in Copenhagen? Because that's where they were located. I'm in Australia, which is pretty much as far away from Copenhagen as I could be. To try and then get in contact with them. But I did. It was 2008, and there was another thing that was kind of popping up that I wasn't particularly interested in. I didn't think it had much longevity, but I found it was a useful way to get in contact with them. So I found them on Twitter. That's how I got involved, and that's how I became the absolute Twitter junkie that I seem to be these days. I had to make sure my phone was on silent so I don't keep hearing pings and go, ooh, someone's messaging me while I'm up here on stage. So I got in contact with them and I pitched them the idea. I was like, here, I reckon this is how we can make the .NET experience for Umbraco a whole lot better. I built a really simple proof of concept over the top of their .NET API, which was actually really just linked to objects over their .NET API. Little did I realize that the part of the API that I'd used to underpin this was painfully database heavy. So every time you wanted to read a property to display on a page or to access a page, it was a hell of a lot of database hits. We actually shipped my proof of concept into a production website and pretty much brought it down. That was not a fun day. But I pitched this idea and they're like, that sounds cool. Do you want to come to our conference in June and talk to us about it? Do you want to come to the core contributor retreat that we're doing the week before the conference, and we'll hack on it together, and we'll put together this idea and we'll get it going? I was like, sure. It's like January. That's like 6 months. Time to get coding, right? Yeah. So I'd never written a link provider at this point in time. I've got 6 months. I can totally get that done. So cracked out Reflector, started poking around. How did link to SQL work? It can't be that hard. I can work it out myself. I'm a smart guy, right? What the heck's an expression tree? I didn't realize that there was iQueryable and iNeural, and they were different things. That's fine. I can totally get around this. It's not really that hard. Wait, I got to parse the method calls that people are doing inside of these expression trees. So if someone does something that equals something else, that's different to if they use the equals operator. And let me tell you, .NET 3.5 RTM version of link and the expression trees was a lot different to the first service pack to that. And I learned all this. If you just had a collection, an iNeural, and you did .select and didn't pass anything in there, that was different than if you had just the collection, just the iQueryable. That was a whole different expression tree. And if you had a where and then did a select, and if you didn't, if you had just the where, then that was an entirely different expression tree as well. And these sorts of things, like, they really hurt my brain. I'm like, I don't know, like, I can totally make this work still. I will get it done. I wanted to have something like the DBML file. If anyone still remembers Link to SQL, you had the lovely schema thing that behind it was this XML, but you had this pretty GUI that you could drag and drop tables onto, and it would generate code under the hood. I wanted something like that. I wanted to be able to take an XML file that represented the data structures that Umbraco used internally and turn those into .NET objects automatically. And I'd never done anything with Visual Studio extensibility at this point. And I'd never done a code generator at this point, but I could totally work this stuff out. I'm one guy that's on the other side of the world to the people building this actual product and just like madly writing code and Googling and like sending out emails for help to anyone that would actually listen to me. But I got it shipped. It was a little bit more brutal than I intended when I finally got it released. It never gained the kind of traction that I was hoping. I thought this was totally going to change the way that we did development in Umbraco, but it really didn't. But I still got it shipped, and I was happy with myself. I got to go to this conference, and it was a complete change of life for me. Like, this thing that started as just a crazy idea that I never thought that I could actually achieve. It was a complete change of life. It was the first chance I'd had to do public speaking. I'd never even been to a user group at this point. I'd never spoken at a user group, obviously. Hadn't really been to a conference, let alone presented at a conference, let alone spoken to members of an open source project that had some notoriety in and of themselves. But that was a massive opportunity for me. Like I say, it got me my start in public speaking. On the back of that, I actually got offered a job. I was living in Melbourne at the time, and I got offered a job in Sydney. So I relocated. I literally picked up my life and moved to Sydney based off of this idea and having built this and going and presenting at this conference. I got my start in open source development. I'd played around with open source projects. I'd pushed something, and this is 2008, Microsoft open source. So it is Codeplex with TFS or TFVC as the backend, or SVN Bridge if you really wanted to go that route. There was no GitHub. There was no real Git. The Git Mercurial source control wars were still a couple of years off. So it was completely different to what it was like doing open source now. I contributed to the Umbraco project for a number of years. I worked with them on an ill-fated rewrite of it called Umbraco 5. I then went to the conference where they actually killed that project that they'd been working on for about 3 years at that point in time. And I was there at the back of the keynote while the founder of this project announced that this thing that they'd spent 3 years on development and countless resources and people had been through training, it was dead. And that was a harrowing experience, like being in that room with 400 people while someone is announcing that the project that they are there for a 3-day conference to learn about is dead. It's exciting. That kind of stuff. That was an intense experience. And this wouldn't have happened without the support of my employer. My employer was really, really encouraging me to get involved in this project. Admittedly, that kind of backfired on them when I resigned after coming back from this conference and moved into state. But so keep that part in mind when I'm talking about motivating people, that it can go to extremes. But it was a really great opportunity, and it all started, as I said, from what could be seen as a bad idea of a junior dev going, I'd totally write a link provider. So the next time that you have an idea or one of your colleagues comes to you with an idea, don't millhouse it up. It's not a stupid idea. Think about the last time that you challenged yourself to just do something that you didn't think was the best thing that you could do or the right thing that you could do. When was the last time you freaked out the establishment? Thank you. Stop with the clapping, you'll kill us all. We've got a couple of minutes if anyone has any questions. There's a microphone around if anyone has any questions. Otherwise, I'll be around for the rest of the conference. Feel free to find me and ask me questions or validate your stupid ideas with me. I'm more than happy to be a sounding board. Or, again, like I said, thank you. Enjoy the rest of the conference.